Okay, our topic today is dividing positive integers and dealing with remainders. Now the term integer is one you should know by now. Integers are just the counting numbers, 1, 2, 3, 4, 5, and so on, plus 0, plus the counting numbers going the other direction, -1, -2, -3, and so on. Those are integers. So what we're dealing with today is dividing positive integers, numbers like 23 and 5 and 4 and 7 and so on, and then how we deal with remainders. Before we do that, we need to know 4 terms. Anytime we're dealing with a division problem, there are 4 words that we need. And those are identifying the 4 parts of a division problem. The first one is the answer to a division problem. If we had 23 divided by 5 is 4, this number is called the quotient. Q-U-O-T-I-E-N-T, the quotient. The number that we start with, the number that we are dividing into, is called the dividend. The number that we're dividing by is called the divisor. And we quite often have something left over. For example, in this problem, 23 divided by 5, 5 goes into 23 4 times. 5 times 4 is 20, so there's something left over. There's 3 left over, and we call that number the remainder. Now that we have those basic terms, I want to talk about 2 different things today. The first one is some strategies for how we deal, the second one actually is how we deal with division, different methods that we can use. But before we get into that, I want to talk just briefly about remainders. Now, you may have seen it expressed in this way before. 23 divided by 5 is 4, remainder 3. That's certainly a fine way to do it most of the time. But the other thing that you can do is you can turn that remainder into a fraction. And the way we do that is we take the remainder, we write it on the top, right there, and we take the divisor right here, and we write it on the bottom. And then the way we would write this problem would be 23 divided by 5 is equal to 4 and 3/5. Sorry, that sort of ran together a little bit, but that's how we express remainders. We can also do it with decimal numbers, but we'll talk about that another time. Okay, now, what we want to talk about is some mental strategies and formal strategies that we can use to solve division problems. I want to pause the video if you don't have this down, because I'm going to erase it for now, so we have a little more room to work with. There are basically 3 mental strategies that we can use that are very effective. The first one is just tables. Now you may be thinking, well, I know we work on multiplication tables, but we don't work on division tables. That's true, but multiplication and division just reverse each other. So let's say, for sake of discussion, that we had 84 divided by 7. Now you might not know what 84 divided by 7 is right off, but what you can do is say, what times 7 equals 84? What times 7 equals 84? And if you've learned your times tables effectively, then you know that that 12 times 7 gives me 84, which means that 84 divided by 7 is equal to 12. So our first method is we can know our times tables really well. The second method that we can use is the distributive law. And with the distributive law, we are essentially going to break the problem into a couple of pieces that are easier to deal with. Let's say that we had, for example, 93 divided by 3. That might not be a real easy problem for you, but what you can think about is this. 93 is 90 plus 3. So we're going to change this problem to 90 plus 3, and we're going to divide each one of those pieces by 3. 90 divided by 3, and 3 divided by 3. So 93, 90, and 3 divided by 3 for each part. Now 90 divided by 3, much easier problem. That's 30. And 3 divided by 3 is 1. Also an easy problem, which gives me a result of 31. Now, the last mental strategy that we can use is called halving. And when we're doing a halving strategy, essentially what we do is we divide both of the numbers by 2 at a time until we get to something that's easier to work with. Let's say, for example, that we have this problem. 128 divided by 8. Now that's a little bit of a complicated problem to do, so what we're going to do is we're going to take both of these numbers, and we're going to divide both of them by 2. 128 divided by 2 is 64. And 8 divided by 2 is 4. Now that problem may still be a little bit difficult for you, so we're going to have them again. And we're going to have 32, 64 divided by 2 is 32, 4 divided by 2 is 2. Now we have 32 divided by 2, which is a fairly simple problem, and that gives us 16. So those are the 3 mental strategies that we can use: tables, distributive law, and halving. Now, if none of those work, we still have the algorithm approach. Just like with multiplication or division, or multiplication or addition or subtraction, we can always use an algorithm. And rather than doing them vertically like you would typically do with multiplication or subtraction or addition, we use this little form that we had a little while ago. Let's say that we had 37 divided by 3. Now, short division, we say, how many times does 3 go into 3? It goes in once. Do we have anything left over? We don't. So then we say 3 goes into 7. How many times? Twice. 2 times 3 is 6. We take that 6 away from 7, and what do we have left? We have 1 left. So we can write it this way, remainder 1, as you may have learned before, or as I said a few minutes ago, we can turn the remainder into a fraction. So in this case, our answer would be 12 and 1 over 3, or 12 and 1/3. Now we can also use this same method for larger numbers, numbers that aren't quite as simple. Let's use 195. Again, that's our dividend. And 7, that's our divisor. And we do the same thing. 7 goes into 1. How many times? It doesn't go. So we go to the next number. 19 divided by 7. That goes twice. We put our 2 there. 2 times 7 is 14. I take 14 away from 19, and what do I have left? I have 5 left. So I write that 5 right there. And then I ask 7 goes into 55 how many times? You should realize that's 7 times. 7 times 7 is 49. I take 49 away from 55, and I'm left with 6, which I can write as a remainder 6, or we can write our remainder 6 over 7. So 195 divided by 7 is 27 and 6/7. Now there's just one other little detail that we want to talk about. We've talked about before the commutative law and the associative law. The commutative law says if I have 2 numbers, let's say 3 plus 4, that's the same thing as 4 plus 3. We're not concerned with what order they're in. The same thing works with multiplication. 3 times 4, which is 12, is the same thing as 4 times 3. Again, the order does not matter. However, this does not work. Commutative law does not work with division. Using the same example, 3 divided by 4, which you should know is 3/4. 3 divided by 4, 3 over 4, 3/4, is not the same. It's not equal to 4 divided by 3. Because 4 divided by 3, that's 4/3 or 4 over 3. 4 divided by 3, those are not the same thing. Also, very similarly, we've talked before about the associative law, which deals with dividing things. Which deals with brackets and getting rid of brackets. If I had something like 2 times, or plus 3 plus 4, that is the same thing as I can move those brackets and have 2 plus 3 plus 4. This is 7, plus 2 is 9, 5 plus 4 also 9. We can do the same thing with multiplication. Let's say we had 2 times 3 times 4 equals 2 times 3 times 4. 3 times 4 is 12, times 2 is 24. 2 times 3 is 6, times 4 is 24. Okay? We cannot do the same thing with division. It just doesn't work quite the same way. And that is dividing positive integers and dealing with remainders.